Good day everyone. Myself Satish Kumar Tayalan. Today my video presentation will be titled as Metrological Traceability. What is metrological traceability? I've segregated it into two, where metrology is a scientific study of a measurement and its application, while traceability is the relationship of a measurement result to a reference through an unbroken chain of comparisons. To make it simpler, metrological traceability means our result is meaningless unless we can link it back to a recognized reference through an unbroken chain of calibrations with known uncertainty. This ensures that measurements performed in different laboratories with different instruments or at different times remain comparable on a common metrological basis. When it comes to the traceability chain, SI units are at the top of the chain with an extremely less uncertainty. The SI units are the ultimate references for all measurements, and all calibration systems must link back to SI to be considered metrologically traceable. Next is the NMI level, followed by accredited calibration laboratories, which acts as the main bridge between NMI and user labs. Then the user laboratory and the user equipment, ending with the final product, which is the end user measurement. The traceability links our measurement back to SI units through an unbroken chain. At every step downwards, the uncertainty increases. Meanwhile, at every step upwards, the traceability increases. To establish and claim traceability, the measurement must be defined clearly. Next, choose and control a suitable measurement procedure. The method itself must be validated and influence quantities. Then select appropriate reference standards. Finally, estimate the measurement uncertainty. Without uncertainty, the traceability is incomplete. What happens if the traceability chain is broken? The short answer is the measurement becomes scientifically meaningless. Without a complete chain back to SI units, the results cannot be compared with other labs, cannot support regulatory decisions, and cannot pass accreditations or audits. The report uncertainty is no longer valid because it does not include contributions from calibrated standards. Even worse, the calibration becomes unreliable and decision errors can occur. Here is an example of metrological traceability in water testing using ICP-MS for lead. We start with the certified reference material NISD1643F, which has a certified lead value. Calibration standards are prepared from a primary lead standard traceable to its reference, and all volumetric equipment is calibrated to ensure their traceability. Before measuring the sample, we analyze the CRM. The measured value gives a small acceptable bias of negative 0.37 microgram per liter, confirming the instrument is accurate. The drinking water sample gives a mean of 11.0 microgram per liter. After combining all the uncertainty sources, the final reported result is achieved at 95% confidence interval. This full traceability chain from CRM to SI units ensures the measurements are reliable, defensible, and comparable across laboratories. That's all from me. Thank you for listening.